Okay, the label on a large can of Hilltop coffee states that it contains 3 pounds or 48 ounces of coffee. A consumer testing agency desires to test Hilltop's claim. Standard deviation is given as 2.88 ounces. And we consider that sigma. In the manufacturing and canning of the coffee, it is probably well understood what the variation of that machinery is, and a very good estimate of sigma would be obtained, called a planning value, and it's given as 2.88 ounces. Suppose you work for the testing agency and are asked by the project director to test Hilltop's claim. The project director gives you the following Type 1 and Type 2 error statements. So in other words, they want the probability of making a Type 1 error to be no more than 1%. That's our typical 5-step procedure, hypothesis testing procedure. The Type 2 error statements, to control Type 2 error, the director wants only a 10% probability of claiming Hilltop is not in violation if they are underfilling the cans by up to as much as 1 ounce. So we need to, first of all, to run this test to satisfy those Type 1 and Type 2 error statements. So the first thing you would do is to find a sample size. Now before, we went ahead and had a sample size, and we investigated the power of that sample to correctly reject the null. And then I guess we're kind of hoping that the power was sufficient, because if it wasn't, then we would have to go and get a larger sample. Well, in a very practical setting, the first thing you would do is to calculate the sample that's going to satisfy your error requirements. So I'm going to use a formula in the book and plug in all the values I need to calculate this sample size that's going to make my error statements true. Alpha is 0.01, so if I look that up, that's going to be a lower tail test. So they want, though the Z alpha is the area of 0.01 in the upper tail. In other words, they want a positive Z value there. So that is going to be 2.33 if I look that up in the table. In other words, that's a 0.01 in the upper tail, so you get the positive Z, even though this is a lower tail test. The beta probability for the upper tail is 0.1, so we get a Z of 1.28, and then sigma is 2.88, and then we're dividing that whole thing by 48, the value we're testing against in the null hypothesis, and then the acceptable value for mu. In other words, mu could be as low as 47, and we're still okay with that, even though the null wouldn't be true. We're willing to go ahead and go down to 47. We want to make sure we reject it for anything less than that, but we'll go down as far as 47. And if I do all those calculations there, I get a sample size of 109. Okay, that's going to help me get a decision statement, and I will go ahead and build that by first of all looking at the sampling distribution. And of course, with the hypothesis test, this is a lower tail test. Our alpha is 0.01, so our Z value is negative 2.33. Our standard error will be the 2.88, divided by the square root. We're using 109 to satisfy our error requirements. We'll get a standard error of 0.2759. And then in step 3, we'll start out with a rejection rule. Reject h sub 0 if z is less than less than or equal to negative 2.33. Of course, z is our test statistic for whatever sample average we would end up with. And to calculate that, we'd subtract the value we're testing against, the average, and divide it by the standard error. And then we would multiply both sides by that 0.2759, solving basically a linear inequality, and then adding 48, we'd have x bar less than or equal to 47.36. So our rejection rule turns into reject h sub 0 if x bar is less than or equal to 47.36. So our sample average that's on our decision line is 47.36. And then we will accept h sub 0 if x bar is greater than 47.36. So this becomes our decision statement or our decision rule for the sample. Question 3 and 4 ask about the results of a sample of this size, 109. Question 3, what if a sample of the size calculated for the decision statement yield a sample average of 45? Well, if the sample average from that sample of size 109 turned out to be 45, then we would reject the null hypothesis. The probability that we would be wrong would be less than 1%. Question 4, what if the sample size calculated for the decision statement yielded a sample average of 47.5? What would be the conclusion of the test? Well, if we took a sample of size 109 and the sample average turned out to be 47.5, then we would accept the null hypothesis. And we would be confident that the null hypothesis is true. We would have less than a 10% chance of being wrong about that, and that was set in our error statement as acceptable. So this concludes hypothesis testing in Chapter 9. We can not only control type 1, but we can control type 2 by setting a sample size, and we can make a decision of either reject or accept. Now, one other point I want to make here is the vast majority of hypothesis testing is just type 1 analysis. A lot of times a company will make run tests, and if they can't get a rejection of the null to prove basically the alternative, then the test is inconclusive. But there are some times where a decision has to be made, and people want to make that decision confidently. So they want to control not only type 1, but in the case that they are faced in accepting the null, they want to control the probability of being wrong about that, or type 2. In that case, we do this procedure. We select a sample size that will satisfy our error requirements, and we run a test based on a decision statement. Please let me know if you have any questions about this, and continue to read the content on this page with other examples and information.